Hi, I am Dalton Mason, and today we will be learning about field effect transistors. Now, what is a field effect transistor? Well, first, JFET stands for Junction Gate Field Effect Transistor. Now, a JFET is a small device utilizing small voltage to control current. All JFETs are unipolar rather than bipolar devices. JFETs are commonly used to amplify small AC signals. Now, the main reason that you would use a JFET instead of a bipolar transistor is that a very high input impedance can be obtained using a JFET. Now, there are two main types of JFETs, the N-channel JFET and the P-channel JFET. But first, we're going to check out the characteristics of a JFET. So pretty much all JFETs have the same four characteristics: the channel, the drain, the source, and the gate. Some JFETs have two gates, and they are called dual gate JFETs. Now, the current flows through the channel in between the drain source. That's kind of how they work. So now we're going to talk about N-channel JFETs. An N-channel JFET is made up of a drain, source, and they have two gates. So there's your dual gate JFET. So the main characteristics of a JFET is the N-type semiconductor material located inside the JFET, actually inside the channel, pretty much right in the middle. Embedded on each side of the N-channel JFET are two smaller P-type regions. The majority of the current carriers in the channel are free electrons. Now, P-channel JFETs. P-channel JFETs are also a dual gate JFET. Inside the channel is a P-type semiconductor, while two N-type regions are on the sides, just kind of like the N-channel, except everything's kind of switched. The majority of the current carriers in the channel are holes, and those are pretty much the main differences between a P-channel and an N-channel, is the holes and free electrons. Now we're going to talk about gate action. The gate regions in a JFET, like I said before, are embedded on each side of the channel to help control the amount of current going through and flowing through. When both gates are centered vertically, it is called symmetrical JFET, meaning the drain and source leads can be interchanged without affecting the actual operation of the JFET. Adding a drain supply voltage will reverse bias both P and N junctions. And that pretty much means the more voltage there is in the gates, the smaller the channel will be, in return controlling the current flowing through. Then with no voltage applied to the source or gate, the channel will be wide open and current will just be free to flow as much as it wants. Now we're going to talk about JFET biasing techniques. Now, the most common biasing techniques are gate bias, self-bias, and voltage divider bias. Gate biases, they're very rarely used with JFETs due to the wide range of JFET circuits. In some circuits, the amount of gate voltage applied may cause a very large drain current, while in other circuits, the same voltage that we just used might reduce the drain current to zero. So there's not very stable, kind of everywhere, not really used for JFETs, more for bipolar transistors. Now, the self-bias, which is probably the best one, it's the most common way to bias a JFET due to how stable it is. And when I say that, I kind of mean like any increase in drain current causes gate voltage to increase. Then the increase in that gate voltage causes the drain current to decrease, offsetting the original increase in drain current, making it stable. Vice versa, a decrease in drain current causes the gate voltage to decrease. Then the decrease in gate voltage causes the drain current to increase to its original value, stabling everything out. So it's definitely the best one. The voltage divider bias, it pretty much can turn a large voltage into a smaller one, pretty much by splitting it down the middle. Divider kind of makes sense. A big downfall to this type is the signals can get mixed up, making it very hard to predict the exact values for voltage and current. So JFET amplifiers. JFET amplifiers are used to amplify small AC signals. There are three JFET amplifier configurations that are commonly used that I'm gonna go over: the common source, the common gate, and the common drain. The common source amplifier, this applies input voltage to the gate and output voltage is taken from the drain. The common source amplifier has a high input impedance and a moderate voltage gain. The input and output voltages are 180 degrees out of phase. Now, the common drain amplifier is usually referred to as a source follower. The input signal is applied to the gate while the output is taken from the source. A source follower has high input impedance and low output impedance. It also has a voltage gain of only 1, if not even that. The common gate amplifier, this input applies to the source while the output is taken from the drain. This amplifier has a moderate gain in voltage. However, the impedance is very low in both input and output. So due to these undesirable characteristics, the common gate amplifier is rarely used when you're dealing with JFETs. Now, I'm going to talk about the MOSFET, which is a metal oxide semiconductor field effect transistor. It's a lot of words for that. So a MOSFET also has a gate, source, and drain, just like the JFET. Pretty much the main difference between MOSFETs and JFETs is the gate terminal in a MOSFET is insulated from the channel. And this causes the input impedance to be multiple times higher than JFETs, than like your regular JFET. So there are two different types of MOSFETs, the depletion type and the enhancement type. So the depletion type can operate with either positive or negative gate voltages. It also conducts the gate shorted to source that can equal 0 volts. Now the enhanced type, there is no channel for conduction between the drain and source terminals. Due to this, the gate voltage has to be greater than the threshold voltage to gain any drain current at all. So that's pretty much it. I hope you learned something. Here are my sources. I mostly just used the textbook to get all this information. This website, I was able to find a few facts on there that I was able to throw in here. But other than that, I hope you enjoyed it and hope you have a good rest of your night.